Today we're going to keep looking at solving rational equations. A rational equation, remember, is any equation that contains one or more rational expressions. We're going to be looking at some examples here in a second, but today when we're looking at some of these with adding and subtracting, we need to be aware of extraneous solutions. An extraneous solution, again, is any solution created by multiplying by the least common denominator, but it is not an actual solution to the original equation. So you get this extra answer that looks like it's an answer, but doesn't work when you plug it back in. Okay, let's take a look at an example. Number one here, we want to solve this out. And just like we were looking at before, you need to get a common denominator in order to add and subtract these different terms and solve for r here. So first off, if you want to look at, can you do any factoring? Is there any possible factoring we can do? Looks like there is. This first denominator that we run into, r squared minus 1, right here, can be factored as a difference of squares of r plus 1 times r minus 1. So any factoring you can do, look to do it. Otherwise, it doesn't look like any of the other terms factor nicely here. This r squared plus r plus 2 is a quadratic but does not factor. So the only factor we can do was that one denominator. So now we got to look, what is our least common denominator going to be? Well, two of these terms have an r plus 1. So this first term is going to need that in the denominator. And then it looks like that middle term also has an r minus 1. So we also need to multiply by r minus 1 to both the first and last term. And remember, like we talked about yesterday, anything you do to the bottom also needs to get multiplied to the top. So here and here, we're going to have to multiply these up. All right, so now that we have that, we want to do some multiplying here and kind of see what this one's going to look like. If we multiply r plus 1 times r minus 1, you should get r squared minus 1 when you multiply all that out, because that's what we had factored it from. That's all going to be over r plus 1 times r minus 1. It doesn't look like there's any simplifying we can do there right now. Okay, now because we're adding these two terms together and they have like terms, we should just be able to write this as one fraction. So another way we could just write that is all this plus this over common denominator. Okay, on the other side, looks like there is some multiplying we could do up here. We should distribute. We should multiply r to all of these, and we should multiply a negative 1 to all of these and see what we get. So if we do that, you're going to get r cubed plus r squared plus 2r. If we multiply negative 1 to all of them, you get negative 1r squared minus r minus 2. All over this denominator. Now, once we're here, if we got the same denominator on both sides, if we were to now multiply by r plus 1 times r minus 1, that should cancel out. And if we multiply the same thing to the other side, those would cancel. So once you get that common denominator, it's really looking at, like we talked about yesterday, just solving the numerators out. What's that numerator going to solve out to be? Well, let's finish solving the numerator. There is some other distributing we need to do here too. You're going to get r cubed minus r plus r squared minus 5 here. On the other side, we got all these terms. There is a couple like terms we can put together. In fact, these two terms would cancel out. And we got a couple like terms we can add together here. So we get r cubed plus r minus 2. All right, now we just got to look to solve out and see what we get. If we were to minus r to the third power here, Those cancel out. So now we're down to this. However, we're not going to be able to solve this out algebraically. Looks like it's a quadratic. We're going to need to get everything to the same side and factor it. So let's minus an r here, add 2, get it equal to 0. Quadratics, we always want equal to 0. So now you got r squared minus 2r minus 3 equals 0. We want to factor this out. What's going to multiply to negative 3 and add to negative 2? Looks like negative 3 and positive 1. So set them both equal to 0 now and solve. And we get the answers of 3 and negative 1. Now, we want to check these. We want to see, do both of these answers actually work? If we put the number 3 back into this original equation, we should get a solution here. If we put a 3 here, 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 and here, we shouldn't run into any trouble. This denominator is going to end up equaling 8. This one would end up equaling 4, and we get some numbers on top, and we should be able to solve it. But let's check our other answer. The other answer we got was negative 1. Will negative 1 be okay here? And you can see, no. If we put negative 1 in here, you get 0 for that denominator. We can't have a denominator of 0 that's dividing by 0. That's not possible. So in this case, there is only one solution, 3. R equals 3 is the only answer. This R equals negative 1 is what we talked about before. That's an extraneous solution. It's a solution that we got by solving, but doesn't actually work when we plug it back in. So only 3 works. So you want to check when you're all done to make sure that it works out. Let's try another one of these. Number 2, we want to add together these two terms. Again, start by factoring. Is there any factoring we can do? One term here looks like it factors. This x squared minus 1 is the same as difference of squares, x plus 1, x minus 1. So yes, we can. Now we want to get common denominator. So multiply this first one by x minus 1. This middle one needs to get multiplied by x plus 1. Do whatever you multiply at the bottom, they'll make sure you multiply to the top. And then our denominators should all just cancel out. So all we got to do is work on simplifying the top here. So on the top, it ends up being 2 times x minus 1. Looks like some distributing we're going to have to do there. Minus 1 times x plus 1 equals negative 2. If we solve that out, that should give us the answers. This first one we're going to have to distribute 2. Be careful on the second one. This is an easy mistake to make. We're distributing a negative 1 because there's a minus sign in front of it. So we're going to get 2x minus 2 minus 1x minus 1 equals negative 2. Combine these like terms and these like terms. Add 3 to both sides. And it looks like we get an answer of 1. Again, check your answer. So let's go back to this original problem here. Does 1 work as an answer? If we put 1 here, we're fine. 1 plus 1 is 2. That's going to be okay. If we put 1 here, uh-oh. That makes that equal 0. We can't have division by 0. This is, again, an extraneous solution. Now, the last problem, we had another solution to go with, so we were okay. This was the only answer we got was 1. And because that was an extraneous solution, there actually is no solution to this problem. There's no number we can put in for x that are going to make these two sides equal. So this one has no solution. All right, let's try another one here. Number 3. On this one, we want to, again, start by factoring. Always start by factoring if you see plus or minus. So what's going to factor out of each of these? Well, on this one, it looks like we can factor out a 3 on this first one. The second one looks like you can factor out a 4, greatest common factor of 4. And on this last one, appears we can factor again a greatest common factor of 2. So now we want to figure out what is our least common denominator. Well, we got these numbers here, 3, 4, and 2. The least common multiple of 3, 4, and 2 is going to be 12. So we want to multiply by something that's going to make all these 12. So this first one should get multiplied by a 4. Make sure you multiply by 4 to the top. The second one looks like you got to multiply by a 3. And the last one by 6. Okay, but then we also have these n plus 1 and minus 1s terms. So both of them are going to need both. So this first one needs an n minus 1, which means we need to multiply by n minus 1 to the top. The middle one at n plus 1, so n plus 1 at the top. And the last one, n minus 1. Once we've done all this, all our denominators should be 12 times n plus 1. So we don't need to worry about them. We just need to simplify the top now. So let's start by doing some multiplying here. If we multiply these, we're going to get 28 n times n minus 1. If we multiply these, we minus 15 times n plus 1. Multiply these, we get 18n times n minus 1. Now we got some distributing to do. Okay, distribute here. Again, make sure if there's a negative sign, you distribute the negative sign. So we want to do a bunch of distributing. Okay, once you're done distributing, now you look to combine like terms. This one appears to be have some like terms in the middle here, so we can combine those. If we subtract those, we're going to get negative 43n. This one is one of those quadratic ones again, though, so we want to get it equal to 0. So let's subtract these and get it equal to 0 and add 18n. We want to solve quadratics equal to 0. So if we do that, now we get 10n squared minus 25 and minus 15. We got to solve this one out now. So check, is there any way we can make this problem easier? This one appears to have a greatest common factor of 5 here. All these terms can be divided by 5. So if we factor or divide out a 5, we can make this a little bit easier. Let's divide all these by 5. Now we got 2n squared minus 5n minus 3 equals 0. This one is a quadratic, so it should factor out here. So let's figure out what's going to make this factor. We got 2n squared on this one, so one of these is going to be a 2n rather than just n and n. And then we know that both of these two last terms need to multiply to negative 3. So it looks like it should be a 3 and a negative 1. Now we got to make sure this works out so that these middle terms add to negative 5. So let's try something. Let's try maybe plus 1 minus 3 and see if it works. If we multiply these, that's 1n. If we multiply these, that's negative 6n. Those two do add to negative 5 now. So now we have them factored out correctly. So the last thing, put them both equal to 0. And see what you get when you solve. One answer looks like 3. The other one, we should minus 1 here and divide by 2. And it looks like you get negative 0.5. So we got two answers of 3 and negative 1/2. Now we've seen in the last two problems we had some extraneous solutions. Let's see if we get them here. Do both answers work out? If we plug in 3, are we going to be okay? Yep, okay there, okay there, okay there. None of those would make it equal 0. Let's try negative 1/2. If we put negative 1/2 in here, that's okay. This one's going to equal 1.5 then, that's fine. Negative 1/2 here, that's fine. That's going to make this negative 6. Put negative 1/2 here. That's also fine. That would equal 1. None of these denominators make it equal 0. So this one actually has two solutions. Both solutions work. So sometimes you might have more than one answer. Both answers are good here, 3 and -1/2. All right, let's look at number 4. Why don't you pause, try number 4 out here, see if you can do it, and then check in a second. All right, let's see how you did. Start by factoring again. All these ones had some factoring. This middle term here appears to factor out. It's a difference of squares. You got p plus 1 times p minus 1. Okay, which means that looks like our least common denominator is this middle one. So this first term should get multiplied by p minus 1. And then this last one has no denominator, so it needs both p plus 1 and p minus 1. So we got to multiply both of those to the top. All right, now that we got a common denominator throughout, we just need to solve the numerator and see what that's going to give us. There is a lot of distributing you're going to need to do here, so multiply this to each and then -1 to each and see what you get. The p cubed minus p squared plus p. If you multiply them all by -1, you get minus p squared plus p minus 1 equals p squared minus 7 plus, and then we got to multiply these. I'm going to choose to multiply these first. You would get p squared minus 1 if you multiply those, because that's what it factored from. All right, now I got to keep going here. Looks like there's a few like terms on this side we could put together. So you get p cubed minus 2p squared plus 2p minus 1. On this other side, let's finish distributing here. You get p to the third power minus p. Some things we can do here. There is a p cubed on both sides, so if we minus that, those would cancel out. So there's what our problem looks like now. Next step would be to get this equal to 0. I'm going to move everything to the right side so that our p squared term is going to be positive. So I'm going to choose to do this. So all these should equal 0. You get 3p squared minus 3p minus 6 now. Looks like all these terms can be divided by 3, so I'm going to do that next. So that's still 0. This would be p squared minus p minus 2. What's going to multiply to -2, add to -1, -2 and +1. So set those both equal to 0 now, and we get two answers, p equals 2 and p equals -1. Go back, make sure both of them work here. Are both of these going to be good solutions? It doesn't look like the -1 solution works. If you put -1 here, that equals 0. So this did have one extraneous solution. Only 2 is an answer. So if you got 2, you did pretty good on that one. All right, last two things we're going to look at here are some word problems. This first one says Brienne and Owen paint houses together. If Brienne can paint a particular house in 6 days and Owen can paint the same house in 5 days, how long would it take them if they worked together? In this problem, it's going to be tough to try to figure out these two by just adding them because they do have different rates that they work at. They don't work at the same particular rate. So in order to do this one, what we want to do is see what we can do to make them the same. And if we could figure out how much they could paint in 1 hour, we could do that. So our first goal here is to figure out how much can Brienne and Owen paint in just a single hour, or I'm sorry, a single day. So if Brienne paints a house in 6 days, that means in 1 day she would paint 1 1/6 of the house. Owen paints a house in 5 days, so in 1 day he paints 1/5 of a house. They're now going to work together, so we want to add this up. And they are going to paint one house together, so we should put this equal to 1. So the only thing we need to know then is how long it's going to take them. Add in our variable for time, and we should do that. So if we add up 1/6 of a house per day plus 1/5 of a house per day equals the one house, now we should be able to solve and answer this one. Well, it looks like on this one, since we got different denominators here, we need to get a common denominator. The common denominator of 6 and 5 would be 30. So we're going to want to multiply this one by 5 and 5, and this one by 6 and 6, and this one by 30 over 30. So what we end up with here is 6 times 5 is going to be 30. On top we got 5 times x is 5x. Here we got 30 on bottom again. 6 times x is 6x equals 30 over 30. Once you get that same denominator, we don't need to worry about it anymore. Add up the numerator, you got 11x equals 30. Divide, and it looks like it takes 30 over 11, which is about, if we divide this out, about 2.7 days. So working together takes them about 2.7 days to do this. So when you can't compare because they work at different speeds, you need to find a way to do it, and the way is to make see how much they can do in one particular time unit. All right, last one, another word problem. It says the ratio of 16 more than a number to 12 less than that number is 1 to 3. What is the number? We talked about ratios back in geometry. You can compare two things by using like a colon, or most of the time in math we want to use a fraction bar to compare two things, so when you're doing ratio. So on this one we want to see what are the two things we're comparing. On this first one it says 16 more than a number, so 16 plus whatever the number, let's just use x. 2 tells us now we're switching to the other side of the ratio, 12 less than that number. 12 less than that number means the number minus 12 is our keyword for equals here. Now it looks like we got another ratio, 1, 2, 3, 1, 2, 3. Okay, we got fraction equals fraction, just like our problems before. Get a common denominator here and solve it out. So this one we're going to need to multiply by 3, and this side we're going to want to multiply by x minus 12. Once you got that common denominator, now solve the top. So if we solve here, looks like some distributing. We're going to get 48 plus 3x equals x minus 12. Get all your x's together, numbers together. So if we minus an x, it's going to be 2x. Minus 48. And we got negative 60 divided by 2. It looks like negative 30 makes this one true. And it looks like this answer does check out because it's not an extraneous solution. All right, you're going to try some of these now on your own.